This video is going to cover the topic of finding a missing proportion. Be sure the date and topic are at the top of the page. The essential question to guide the video is how can we use proportions to find missing values? And we've been looking at proportional relationships. And a couple things are true about proportional relationships, but one thing that we're focused on for this video is that all data points in the proportional relationship have the same ratio. That's going to be very important. We see this in things like walking rates. If I know that I can walk 5 miles in 40 minutes, then I can infer that it will take me 80 minutes to walk 10 miles. Because if I'm going twice as far, I would need to have twice as much time, right? That's kind of what we think about when we think about proportional relationships. When checking for proportional relationships, we can look at tables and examine that ratio to ensure they're all the same, right? And we do that by looking for that constant of proportionality when we divide our y value by our x value. So I can take a look on here. Let me just change my color so I can see it. And I can do 20 divided by 10, and I know that that's 2. And I know that 40 divided by 20 is also 2, and 160 divided by 80, is also 2. So this is proportional, right? Because they all have the same. We can use the idea of equivalent ratios and the constant of proportionality to find missing information, right? So in this table, we have the price of some Oaks Park tickets and how many tickets you're getting, right? So we can look and see what the unit rate, or K, is for each of these. And that will help us figure out how much it would cost if we wanted to get 15 tickets to Oaks Park. So if I check in each of these, right, I'm noticing that I get the same value. The unit rate, or K in this case, is 4. And I can use this in a couple ways to figure out the price for 15 tickets. One is that I could make an equation. If I know that it's $4 per ticket, according to my constant of proportionality, then I could say the P for price is equal to 4 times the number of tickets, right? And I can just solve, the price is $4 for each of my 15 tickets. The price would be $60, right? And I could figure it out that way. But I could also use equivalent ratios, something that we did more in 6th grade. And I could choose any set of the ratios here to use. But if I know that it was two tickets cost $8, then I would say, 15 tickets would cost how many dollars, right? And I could figure out that way. And I think I'll use the letter N to say I don't know what the number is. And from here I could think, this times 4 made 8. So to keep these equivalent, I'd multiply this times 4 and get that 60 that I had talked about, right? But also last year, at some point, we mentioned something called the butterfly method. And that tells me that these diagonal products are equivalent. So whatever I get when I multiply 8 times 15, it's the same that I get when I multiply 2 times whatever this mysterious number is. And since 8 times 15 is 120, I think to myself, 2 times what is 120? 2 times 60. And I get the same answer again in a different way. Here's another table, and this time it is the relationship between Oreos and the calories that you're consuming. So we filled in what we know, and we're looking to figure out how many calories there would be in 13 Oreos. And we'll try this both ways, similar to what I did on the previous page. So we can look for our K value, right? And we can say, 106 divided by 2, 212 divided by 4, 530 divided by 10. In every single one of these, it works out to be 53. So our K value is, of course, then 53, right? That's the unit rate of calories per Oreo. And I can use that for my equation, y equals 53 times the number of Oreos. And if I'm trying to figure out how many calories there are in 13 Oreos, I can solve it like that, which works out to be, I believe, 689 calories. So that's one way. I can also set up equivalent ratios. And just choosing one of my ratios here, I have 2 Oreos for 106 calories, which would mean 13 would be some number I don't know yet. So I have some options. And this time I'm going to start with an option looking horizontally. So I could think to myself, 2 times, let me think for a second, 6.5 is 13. So I can multiply my 106 by 6.5 and get that same 689 calories. That's one way to do it. Or I could also use that butterfly method and say, I know that this product of 13 times 106 has to be the same thing as the product of 2 times my mystery number. And once I punch that in, I find out that this side is 1,378. This side was 2 times something. So I think, what times 2 makes 1,378? So I divide and find, it's 689. Same answer, a different way. There are multiple ways to look for a missing value in a ratio, and the option that you choose, of which I've recorded 3, will depend on what's easier for the numbers you're working with, right? Be flexible in your thinking and choose the one that makes sense for the particular problem or situation you're looking at. So that being said, I'm going to leave you with a question to finish, and I want you to choose the one that makes the most sense for you to use to solve this. The table shows the price of tickets for a certain number of tickets that you've purchased at, say, the Moreland Theater, right? So use a strategy that works for you, and I need you to come into class tomorrow with this value filled in, right? The price for 13 tickets for you and some of your friends, right? So you can choose whatever strategy here works for you, but we want to know how much it costs for 13 tickets. And remember that the essential question for the video was how we can use proportions to find missing values. The video showed a few ways. There are lots of good options out there, and mathematicians use different strategies in different situations just because they're so flexible in their thinking, just like you will be. Be sure to bring your notes and any questions you might have in class tomorrow.